So this little inequality comes up all the time in analysis, and by the end of this video, I'm going to show you guys an intuitive way to recall this inequality that maybe you haven't seen before. So this inequality is called the AMGM inequality. It says that for any list of n non-negative real numbers, their arithmetic mean is going to be greater than or equal to their geometric mean. And so for the rest of this video, we'll just consider the n equals 2 case, but the higher dimension case is analogous, both in proof and in intuition. So before we get started with the intuition, let's show a quick little proof of this inequality. So we start out by noting that this is actually non-negative, right, because it's squared, and then we just factor this polynomial. And from here to here, what we're doing is we're summing and subtracting this term 2 times xy. And then here we just factored in reverse, right? We got to simplify this polynomial into x plus y squared. And then from here to here, what we did was we sent this minus 4xy to the other side, so we added 4 times xy to both sides. From here to here, what we did was take the square root, and then we just divided both sides by 2. And so this is the AMGM inequality in the n equals 2 case. Okay, so this is the first proof. Now, if you want to just skip over this entire part of the proof, you can just look at this image, and so this is a shortcut to this part in blue here, and you can pause the video here if you want to think about that further. So this image is actually just equivalent to skipping all of this. Okay, so now for the intuition. Why is it that this geometric mean is less than or equal to this arithmetic mean? So to answer that, let's look at these three rectangles. So we have the rectangle which is actually a square of side 3, and we have the rectangle of side 2 and 4, and of side 1 and 5. Note that they all have the same perimeter. So they all have perimeter 12, but the area of this rectangle here is much greater than the area of these other two, even though they have the same perimeter. So we can deduce that given a fixed perimeter, squares will maximize the area, at least among all rectangles. And what this implies is that given a fixed area, squares will actually minimize the perimeter, right, among all rectangles. Okay, so now let's look at the AMGM inequality again. So this is the AMGM inequality, and we'll just multiply both sides by 4. So the AMGM inequality is actually equal to this guy here. Okay, so now look at these two rectangles. So these two rectangles, so this is a square of side length square root of xy, and this is a rectangle of side x and the other side y. And note that they both have the same area, xy. So they have the same area, so like we mentioned here, given a fixed area, squares will minimize the perimeter among all rectangles. So these two rectangles do have the same area, and so this left one, which is actually a square, must have the smaller perimeter. But what is the perimeter of the square? Well, the perimeter of this square is 4 times the square root of xy, and the perimeter of the rectangle is 2 times x plus y, right? Which is exactly what we have here. And so this proves the AMGM inequality. So the AMGM inequality, all it says is that given a fixed area, squares will minimize the perimeter.